lesson 38 notes video. So in this one, our last new lesson of the year, we're going to work on finding domain of a log, rational, and square root function, okay? So make sure you take a look at this. Make sure you get your stuff done for the practice. The lesson 38 practice here is a paper assignment to submit through Canvas. So make sure you double check that because that's where you're going to end up turning that in, okay? So first off, let's review what is a domain. So if you remember, we did domain talking in Unit 7 about all the different functions, and we studied 9 different functions. 6 of those functions have a domain of all real numbers, okay? So those functions are linear, quadratic, absolute value, cubic, cube root, and exponential. So right here, we're not worrying about those, because if you have any of those 6 graphs, and you're asked what the domain is, you just say it's all real numbers. The graph could shift up, down, left, right, reflect, stretch, compress, and it's still going to have a domain of all real numbers. So really, these are the 3 functions out of the 9 we've studied that do not have a domain of all real numbers. So the first one would be a square root. So here's our square root function, as you recall. You can't take the square root of a negative number, so therefore x would have to be greater than or equal to 0. Okay, for a log graph, you can only take the log of a positive number. So x would have to be greater than 0. So the real difference here is the square root can equal 0 and the log cannot. And then the rational graph is 1 over x. Well, you can't divide by 0. So anything that would cause the denominator to equal 0 would be a value that x could not be, or what we would call a restriction on the domain. All right, so let's look how that looks with one of each type. So here's a square root graph. It asks us to find the domain of this graph. So there's 2 different ways. One is we can graph it. So if you opened a Desmos calculator and graph this, this is what the graph would look like. What you would want to do is to find the domain, find the lowest x value. Well, that would be this point. Since that's a closed dot, it would include that value. That was at negative 0.75, or we could write negative 3/4, either way. And then we'd put it with a bracket. Okay, because it could be that value. And then this side, it goes right forever. So it goes to infinity. You'd put a parentheses around it because you can never actually get to infinity. All right, so what's the second method? Since we can't take the square root of a negative number, that means the expression under the square root must be greater than or equal to 0. So we take whatever the radicand is, and we say, hey, this greater than or equal to 0. So 4x plus 3 greater than or equal to 0, and then we just do algebra 1. So minus 3 divided by 4, we get x is greater than or equal to negative 3/4, which you could still write it this way, or obviously that would mean if it was greater than or equal to negative 3/4, it would be from this value to infinity. All right, so let's look at it. So how would I find the domain of this graph? Well, again, this is a square root graph, so one way I could do it is algebraically. So I'm going to say, I need 7x minus 24, and then what I'm going to say here is, oh, okay, well that needs to be greater than or equal to 0, right? So it needs to be greater than or equal to 0. And then I'm going to go ahead and solve for this value. So from this point, I'm going to add 24 to both sides. I add 24 to both sides. When I do that, I get 7x greater than or equal to 24. And then I'm going to divide by 7 on both sides. So I get x greater than or equal to 24 over 7. So therefore, that's what this value would have to be. So we could say bracket, 24 over 7, comma, and then to infinity with a parenthesis. How would this look like in a Desmos graphing calculator? All right, well, if we open up a graphing calculator for Desmos, and then what we'd want to do is just kind of copy this function so we can see what we need to see. So we go in here, we put this into we put this into the graph. Now I'm going to click on this point, 3.429, which is the exact same decimal as 24 over 7. And then where does the graph go? Oh, it goes out to the right. So it's everything from this point greater than or equal to. So it'd be the same thing. All right, so then that was the square root. So what about the log function? So f of x equals the log 2x minus 5. All right, so if we have the log 2x minus 5, so we could graph it, same thing here. We'd see this, where does this lie? So whatever this value is, that's how we find the domain. But it's going to kind of be a little tricky here to find because you got to figure out what's this value of x that's getting closer and closer and closer to. So it's basically from that value to infinity, okay? So it should look like that. Okay, so from this value 2.5 to infinity, or we can do the same thing. This inside greater than 0. Okay, so then we would solve. Remember, it must be greater than 0, so it doesn't have an or equal to sign. So now we can add 5 to both sides, divide by 2. X is greater than 2.5, so we get 2.5 to infinity. Okay, again, let's show it. So here I've got the log 15 minus 9x. So if I do that here, I'm going to have to type that in. So I'm going to get 15 minus 9x, and then that's got to be greater than 0. Okay, so now my algebra steps from here are going to be to minus 15 to both sides. When I do that, I'm going to get negative 9x is greater than negative 15. Now I'm going to divide both sides by negative 9. When I divide both sides by negative 9, then remember I divided by negative, so I have to switch the sign. Let's remember that algebra 1. And then 15 over 9, well, first off, a negative over a negative is a positive. And then I might as well reduce my fraction. So I'm going to actually get x is less than 5/3. So if I wanted to write it in interval notation, it would look like this. Negative infinity to 5/3, parenthesis, because it doesn't include the or equal to. Again, couldn't we graph it? Of course we could. So you're going to pop that in here. Let's go ahead and replace it. There you go. And then you would notice, hopefully pretty quickly, hey, when I look at this, right, this value here, I'm getting closer and closer and closer. See how I'm at 1.66, 1.66? So that's going to tell me that value. And then it's everything below that value since this is to the left. So that's why this would be a less than if you're looking at the graph. All right, now what about it for the rational function? So that's where we have a fraction and the variable's in the denominator. So one way to do it again is to graph it with Desmos. We graph it and then we look for these vertical asymptotes, so those lines that it cannot equal. Whatever those values are, that's what x cannot be. So in this case, it couldn't be 2 and it couldn't be negative 2. So we say, hey, the domain is, this symbol means all real numbers except it can't be negative 2 and 2, which is why you have the equals with a line through it. Or, how do we do it algebraically? Well, we can't divide by 0, so let's set the denominator equal to 0 and solve. So we set this equal to 0, well I get x squared minus 4, so I could factor that into x plus 2 and x minus 2. So then I get x plus 2 equals 0, set them both equal to 0 and solve, so I get x equals 2 and negative 2. So those are the values that x cannot be because it would make the denominator equal 0, which we know we can't do because you can never divide by 0. So we get to the same answer, which is all real numbers except negative 2 and 2. Alright, so let's show that with one extra one. So here you go, I see x squared minus x minus 20. So on the one hand, I could type that in, x squared minus x minus 20. When I do that, I would need to factor. So I need two numbers to multiply negative 20 and add to negative 1. So then that hopefully pretty quickly for you should be x minus 5 and then x plus 4. So then if those are the factors and I set this equal to 0, hold on, sorry. And I set this equal to 0, well then this would also need to be set equal to 0, and then you'd set each factor equal to 0. So you'd have x minus 5 equals 0, and you would also have the x plus 4 equals 0. So what would be your two solutions? You would get x equals 5, and then you would also get x equals negative 4. So those would be the two values that you couldn't have. So then the way you would write it, you would put all real numbers except x cannot equal negative 4 and 5. And so that would be your answer. Again, you could do it by graphing. You would copy this whole thing, and then you would put that into Desmos. And when you put it into Desmos, you need to identify those vertical asymptotes. And you can kind of play around with it, like put x equals negative 5. Oops, that intersected. Let me do negative 4. There it is, right? And then you could do it, 4. Nope, that intersects 5. There it is. So you could play around with those to identify them. All right? So that's how we find the domain from both the rational graph here, from the logarithmic graph here, and then from the square root graph here. Hope this helps.